Hi, everyone. Welcome to our roundtable discussion on accepting multiple approaches and time-saving tips to problem solve on standardized tests, while also demonstrating how to implement the mathematical practice standards. My name is Audra Christ, and I'm joined by Maria Sorace and Brian Simeone. We are the instructors for all of the online courses in the NJCTL Mathematics program. Now I'll turn it over to Brian, who has an interesting story to share.
Thank you, Audra. Recently, I was tutoring somebody, helping them to prepare for the SAT, and we explored what I was considered a thought-provoking and, dare I say, even a fun problem. Here was the question we encountered. It says that given 3x minus y is equal to 12, determine the value of 8 to the x divided by 2 to the y. You can see on the screen that this is a multiple choice question, and calculators are permitted.
This is an intriguing question. There are several ways to approach it. The numerical values for each of the answer choices are 4,096 for choice A, 256 for choice B, 64 for choice C, and then, of course, there is the dreaded option D. The value cannot be determined from the information given.
I think it's important to note that many times, especially on the SAT, calculator permitted does not necessarily mean calculator needed and can be misleading. Brian, how did your student approach this problem?
Well, the student I was working with, the first thing out of his mouth was, obviously, we solve for y. So he proceeded to do that, and he got y is equal to 3x minus 12. Then he asked, where'd I go from there? He stared at it for a couple minutes. I gave him a few minutes to think about it, and finally his reply was, I'll go with D, there's just not enough information.
It's common for students to draw that conclusion with these types of problems. When we teach solving in coursework, it always implies solving for a variable, but not often do we emphasize solving for a quantity. In this problem, we don't need to solve for x and y individually prior to substituting values into the expression. We only need to find the common relationship between the equation and the expression. For example, if he would have recognized that 8 is equal to 2 to the third power, he would have gotten further with the algebra.
Exactly. Once that substitution is made, a student can apply exponential rules to determine the answer 2 to the 12th. By then, after replacing the 8 with 2 to the third and getting 2 to the 3x in the numerator, we can substitute the y for the value found, the 3x minus 12. And now we can notice that the 2 to the 3x in the numerator and the 2 to the 3x in the denominator can cancel out, leaving 2 to the negative 12th power in the denominator. Another rule of exponent being that to change the negative power to a positive, we move it to the numerator. So 2 to the 12th power is your answer.
In the fourth expression, he could have also noticed that subtraction in the exponents would have made a fraction in the denominator. So it would have been 2 to the 3x divided by 2 to the 3x over 2 to the 12th. The way to remove this would be to multiply both the numerator and denominator by the reciprocal, which would be 2 to the 12th over 2 to the 3x. And now we can see that the 2 to the 3x's cancel out, leaving us with the final answer of 2 to the 12th power, which was answer choice A.
Our method towards a problem should always be relevant to the task. Since the SAT is a timed test, there may be a quicker approach to solving this problem. Brian, you mentioned that the student got stuck when the substitution for y was occurring. How could he have worked through this problem without that step? For example, what if he did recognize that 8 was 2 to the third, and then got stuck with the x and y still being combination in the expression?
Well, I did prompt him to remember that 2 cubed is equal to 8. And when he saw that, when I saw he could not progress any further, I wrote the exponential rules out for him. And we applied the rule of exponents just in a slightly different order than you mentioned before. We recognized the power rule in the numerator, that 2 cubed raised to the x power. In that case, you would multiply your exponents to obtain 2 to the 3x power. And then in the next expression, we noticed we were dividing exponent terms with like bases. So we subtracted our exponents and we obtained 2 to the 3x minus y. And at that point, he recognized there was a direct substitution. that entire quantity, 3x minus y, is equal to 12. So we did a wholesale substitution, and that's how we got the same answer choice A, 2 to the 12th.
That, I think, is the tricky part about this method, is recognizing that there is no reason to solve for x and y separately and get quantitative values for them. By simplifying the expression to a point where we obtain 3x minus y as the exponent, we already know that the entire value is 12 and therefore can substitute the entire quantity.
Educators should be mindful that solving for a single variable out of habit isn't always the best option, and that the rules of exponents are true regardless of the order in which they are applied.
I agree, Audra. It is important to mention that today we have also demonstrated several mathematical practice standards. Brian's student demonstrated perseverance by continuing to work through the problem and not giving up, as well as quantitative and abstract reasoning when making the connection between 8 and 2 to the third being equal. Brian, you then continued to implement 2 more standards by helping him look for and make use of structure to break down the problem, and then used appropriate tools strategically to solve the problem without the use of a calculator, despite the fact that you were allowed to do it. For the record, you can find all the standards at the following PDF file.
These are all excellent contributions. That's all the time we have for today. Thank you both for joining me and sharing your expertise. Join us again at our next roundtable.